Can you guys tell me about what exactly we have, discussed in our last session? Just couple of lines to summarize.
Um, so in the last session, I think we discussed about the array index bound out of bound exception and null pointer exception, arithmetic exception, and which has runtime, unchecked exception, and checked exception, and also the finally exception.
Okay. And what else?
I think that's what we discussed on
Okay.
Thursday, I think.
Yeah, just to add few more points to what Varsha said. So we spoke about these keywords, right? The try, catch, finally keyword and how they basically work, right? In the try part, you put out the statements you want to monitor where you suspect some error might come, right? And you might have a catch block, and it can be a multi-catch block where you can return multiple catch blocks. And we understood that whatever exceptions that you specify in a catch block should be in a hierarchical order like this. And we also understood the exception and throwable class hierarchy, right? How they are basically there in Java library. Throwable is the superclass, and under that you have the exception and all. We understood this hierarchy, right? Basically exception hierarchy. And your when you write multiple catch statements, they should also follow the similar hierarchy from uh, child class to parent class. That's how the hierarchy should be. Like if you write exception first and later arithmetic exception, and arithmetic exception would be never be reachable, right? Because the parent class automatically handles it, right? So we talked about multi-catch and also specifically the hierarchy on how it should be there, right? And we also spoke that if there are like 20-30 lines that you wrote in your try block and there is a 10th line, the rest of the statements after that line will not be executed, right? But whatever you written in the catch and finally will be executed accordingly. Okay, so this is what we basically saw in our last class. So today we are going to talk about the throw and throws keywords. Okay, throw and throws. So what exactly is throw and throws, right? Like say for example, I'll take this one and yeah. For example, in the same example, whatever we wrote in our last class, right? This particular exception demo class. Suppose this is the code in try, okay? So I can basically call here some method, right? Like say for example, or here itself, I can use, first we'll talk about throw keyword, okay? So using throw keyword, we can basically, throw the exceptions, right? And we can catch them. So basically, explicitly, we are throwing some sort of exceptions, right? Like say, for example, here we can throw uh, null null pointer exception sort of, right? On new, null null pointer exception. Okay. Basically, I can throw a null pointer exception like this. So that means I can check a certain condition, and if I see that condition is basically met, I can throw an exception like this. So in this particular hierarchy, if at all I call this throw new null pointer exception, what will be the output? What will be the output, guys, here in this scenario? Which catch block will be executed? Which catch block will be executed, guys?
The first one.
The first one will not be executed because you're throwing null pointer exception. First one is catching only arithmetic, right? So why the first one will be called? I mean, it will call, but it will check for only arithmetic exceptions. But
Right. Invalid array.
that is not also array index out of bounds exception also. It will not be called because you're throwing null pointer exception. Okay, so it will call this particular catch exception because these are looking for a specific exceptions, but your exception is a parent class. Your null pointer exception is a subclass of exception. So this catch will be called and this will be the output. Okay, let's just quickly see that. Okay, here you can say, right, uncaught error. This one, this is the first message that got printed. Right. So this is how it is. Okay. So using throw keyword, just simply remember that we can throw an exception manually, right? Rather than some event happening from code. Okay. So if at all you want some real-time examples, suppose you're querying for some employee details. Okay. And those employee details are not found in your system, right, in your database or something, and you want to create an exception saying that employee is not found, sort of you want to create some exception like that, right? So what we can do is, how we can actually approach this particular problem is, you will take some employee ID and you are querying your database and you haven't got any output from that particular query, whatever you made to database, right? For example, you got 0 as a result. 0 means there is nothing found, basically, sort of, right? So then, like, your database query returned a 0 results. That means there is no data found for that particular employee. So what you can do here, you can put an if condition there and check if the records are sort of 0, that means employee not found. So you will say throw new employee not found exception, sort of something like that, right? So these are some real-time examples where you can use the throw keyword. Okay, and then you have a throws keyword, another keyword here, right, in the slide. This is what throw is. And coming to throws, it is basically it's like, suppose we have a method, right, Java method, and it is basically capable of causing some sort of exception which, it basically doesn't handle. Then that method should basically specify that it is going to throw some exception, so that whoever is calling that exception can basically defend themselves against that exception, right? So I'll just give you some example, like say,
Sorry.
Yeah.
So I just got disconnected. Could you explain one more time about why it was showing the uncaught error instead of?
Okay. See here, you're throwing null pointer exception. In the first one, you are catching only arithmetic exception, so it will not be caught here, right? And next it will move here. Here you're catching array index out of bounds exception. So it will not be cached here also. Okay. Then comes the catch. Here you're just catching the general exception. So I told you all these sections are subclasses of exception. So here it will catch this null pointer exception. Null pointer is a system defined exception which we saw some time ago, where you assign strings some null, right? So this exception will be caught here, and this is how it will print because of that exception hierarchy. Okay, your null pointer exception is subclass of your exception class. So that's why your exception class can catch this exception here. Okay. So using throw, the idea is you can throw exceptions as a programmer. You yourself can throw some exceptions. And I just gave example of some real-time scenario, right? Like where you query for database, and in database you're querying for some employee details in your database, right? And you couldn't find the employee details. So in that case, you can throw some exception saying employee not found exception. So you can throw some your own exceptions, right? So that's what it is about throw keyword. Okay. So now I was actually explaining about throws keyword, which is which will be used in a scenario, right? Where if you have a method which is capable of causing certain exception, which it is not handling, but it must basically specify this behavior. So whoever is calling that method will kind of guard themselves against that exception. So to understand this, I'm just creating one method. Okay, so the demo exception, like for example math. Okay, I'm creating a math exception or probably division div division. I am just creating one method like this. Okay, div and int a comma. Okay, so basically you have a method like this. Okay, and I'm just commenting everything, guys. Just commenting everything. Suppose here, let's assume I am calling the div method. Okay, div of 6, 2. Okay, since this is instance of class 𝐸𝑑emo, I need to create that instance. Okay. Okay, so this is how it is, and I'm just comment. So what will be the output here? What will be the output here, guys?
3.
Yeah,
Sorry.
it will just print the result, right?
Yeah.
Right. So now I'm giving like this. What will be the output?
It will give a error.
Error or exception?
Null pointer exception.
It will give exception. Null pointer exception.
Oh.
Why null pointer
It
exception?
was something divided by 0.
It will give arithmetic exception
Arithmetic.
saying it's a mathematical operation, right? So it will give
Right, right.
arithmetic expression saying
Yeah, sorry.
by 0. Okay, null pointer exception definitely no. Okay, so now you have some method like this, right? But you know, sometimes you can here you're not actually handling the exception. Are you handling the exception here for the first time? I mean, in your when you write some programs, sometimes you may find some functionality already available in some methods like this. Okay, so here example, you decided to perform division. You already know that eDemo class has some division method which will do it for you. So you no need to write this logic. I just took a simpler example, but in real time, it can this method can be doing so many things, right? So you know this method is already doing so many things. So you may want to reuse it. Okay. But what if it is what if some exception is happening inside that method? How do you tackle the scenario? End of the day, our goal is to identify possible areas where we'll get exceptions and handle them, right? So how do you handle here?
By explicitly like using a throw exception.
Why? See, I think you haven't understood the problem. The problem that I'm saying here is there is some method like division. I don't know that there is a possibility of exception in that. I just don't know that there is so much code in it that because of some data, it may cause certain exception at runtime. Okay, I'm just giving you a possibility what division that div method is capable of. Right now, I thought I need to do some operation and I felt that this is already being handled by div method. So I just want to reuse it here. So that's why I'm calling the div method by passing supplying input. But I'm not expecting that it should return error, but it is giving me an error. Since I'm not expecting it, I'm not handling it. Okay, if I would have expected this kind of error, then I would have handled it, right? I would put a try catch block and uh, everything would have gone smoother, right? Why? How can I tackle this situation? You understood, right? You guys understood the problem statement? How can I handle the exception here? I want to handle this exception. What should I do?
So you're saying how can we handle an exception that would
Yes.
that can
In
be present in the operation of the
Hmm?
that can be presented in the operation, like in the method, for example, if there is some operation in the method, then we have to handle that exception, right?
So what do you suggest would be the solution to handle? How should we handle? You're calling certain method for some functionality. Okay. Your method is throwing that exception. If at all you write the code like 6 by 0 here, you would know that you're dividing by 0, something like that. So you would put a catch here. So here, in this scenario, what you will do? Just think. How do I handle exception here in first place?
Try catch.
Try catch. Where I'll put it?
Right before the right before you call the method.
All right. So basically, this wherever I'm calling the method, not right before. So inside inside I should enclose it in try catch like this. Okay. Exception key something like this, right? So here I can basically catch that exception. Okay. So now if I execute this, so now I am handling the exception. Okay, even though I'm dividing by 60. So this is what we tend to do normally, but what methods can also do is they in the first place before even if at all, so this is how we will do it. Okay, but let's assume you didn't realize that your method is throwing exception, then it's a problem, right?
Right.
If you're unsure, you would never put the call to method in a try catch. If you're sure, you'll put it, right? Yes or no?
Mhm.
So how can we ensure that whoever is calling certain method, they are aware of that particular method may possibly throw some exception? How can we ensure that? We can ensure that by using this throws keyword. Okay, so here we will say throws and I'll say arithmetic. So this is how I'll do. Okay, so that means the moment I do this, why is this application? So here my method will basically tell those arithmetic exception. Okay, so basically when I tell this, I am automatically supposed to kind of I'll just pick some other method. I don't know this. So yeah, probably let me just do it here then. Throws. I'll just simply say throws just exception. I'll say okay. Now I'm trying to call the class A's. Okay, this is an abstract class. I'll just pick another one. Class F. I'll just copy the same part here into class F. Okay. So now I'm just trying to make use of class F here. Okay. F object equal to of F. And now I want to call the method of F, which is basically this method, show A. Okay, show A. That's it, done. But when I'm calling, this is giving me compilation error. If you observe, what is the error? When I'm calling this show A method, it is giving me an error. What is the error? Unhandled exception type exception. That means when I'm calling show A method, we are basically telling that this method is capable of throwing some exception using this throws keyword. So whoever is calling that method should always put the call to that method in a try catch. So to resolve this error, right? If you don't put, it will give a compilation. To resolve this error, I'll just put this in a try catch like this. Okay. So that's what it is. Okay. So throws keyword is all about that. So whoever is calling the method can basically handle that exception for you. Now this error is gone, right? The whatever error that is coming error. So that means if a particular method is capable of throwing some exception, we can indicate that using throws keyword saying that particular method will possibly throw an exception. So whoever is basically calling that method will be able to put that particular method call in a try catch block in order to handle that exception. Understood, right? This is what throws keyword is all about. Clear? Any queries here?
So throws keyword is normally used for the method exception.
Right. In method signatures only we will make use of
Okay.
throws. But
Okay.
throw we can use, you can use anywhere. So here I can say throw. I can write arithmetic exception here. Right. So new arithmetic exception. Okay. Like that. Okay. So just to understand the difference. You can use throw anywhere from the program. Okay. Clear, right? Any questions? And yeah, now we are going to talk about how can we create our own exceptions. So that means basically a user defined exceptions. How can we create our own exceptions? Okay, so basically your Java built-in there are so many exception classes. They basically handle most common exceptions that we may come across, right? But if at all there is some scenario where we don't want our own sort of exception, right? For example, the example that I was quoting you some time back, where you are querying for employee details in a database and those details are not found, right? So how do you actually handle this, right? Uh, so we can create one exception like this. Okay, throw new class. We can say employee. Okay, not found, not found, found. Exception. Okay, if you see here, I created one exception called employee not found exception. Okay, and this is my custom exception, right? This is not available in Java library. Employee not found exception. This is the exception I am trying to create a new exception, right? Employee not found is not like really available in Java. So to make use of this, what I'll do is I have to extend the exception class, the base class. Okay, and apart from extending this, I need to kind of create one constructor which will basically right. So here what I will do is, right, I created one particular exception now, like employee not found exception. So here I can create one constructor, employee not found. Probably let's assume this is expecting some string str. Here you can try super. str. Okay, so basically you are querying for some employee details. Okay, and whenever that employee is not available, you basically simply want to throw your own exception like this. Okay, saying employee not found exception, and you want to pass the name and you want to print this message: employee with name is not found, some message, some specific custom message you have to throw. So this is how you approach it. Okay, but to actually throw this, what you will do here, right? So I can just simply throw here upon checking some condition, right? I can 𝘘𝐻𝑟𝑜𝑤 throw new, let's say employee. Okay, employee not found exception. Suppose we are looking for employee named Dave. Okay, right? We are looking for employee named Dave here. I'm just trying to command the method call here. Okay, so that means I can check for some condition and for my own exception here. So here I'll just catch that exception and I'll say, probably I'll just simply say ex.get message. So now when I execute this, what is the error it is saying? We are checking for employee Dave, and here I am throwing the exception. So here I'm getting the exception. I'm just printing the message here. Employee with name Dave is not found. So where we define that exception here, over here, we defined that. Okay. So this is how we can create our own exceptions and throw them. Okay. So here you can write a code, where database code, where you will try to check, find employee details with the name Dave. Okay, if at all you couldn't find any employee details, then you can throw an exception like this, the custom exception. This exception you created yourself. This exception is not provided by Java for you. Okay, so how do you, this is how we create a user defined exception in Java. Okay, so you create it by extending exception class, and in the constructor you should make a call to the the exception constructor. You should make a call. Okay, so that's how. And you can write your own custom messages here. If at all you want to put a specific custom message, you can just put it here, right? So that is how you create your own exceptions, and it's called as user defined exceptions. Okay, any queries here? This is an important thing. Okay, in general, in a real-time example experience, we will create so many user-defined exceptions. So based on functionality of your particular application that you're working on, right? So you will be end up creating so many user-defined exceptions. So it's a regular thing we do in our day-to-day programming. So here I created employee not found exception. Then you may create your own custom exceptions based on your development requirement that you're working on, and then this is how you handle with it. Okay, if at all you create some API which would return certain information, and that API is capable of throwing some business related exceptions, right? Like this employee not found. So you can create them as user defined exceptions. Okay. Any more queries on this topic, exception handling? We are done with exception handling, and it's a really important concept in Java. Okay, you will definitely face some interview questions from this area, right? They may ask you difference between what is throw and throws, right? And they'll ask you what is, they'll just probably, tell you, give you some sample code and ask you to identify some sort of exception in it, right? Problem in it, or they may ask you what is user-defined exception. User-defined exception, or they are also called as custom exceptions. So both are same, right? So these kind of questions you may face in exception handling. So any questions here? So before we move on to our next topic, multi-threading. Any questions? Any questions, guys? Okay. So I take that as a no. Fine. We'll move on to multi-threading, right? The next most important concept of Java, right? So basically what is multi-threading in general, right? So to understand this, we'll just talk about a little bit of certain thread basics, okay? So normally if you see, you have a Java running here, right? Like in my laptop, this is my operating system. Okay, this is my operating system. So here I have Java running. Okay, and here you have another thing running like Zoom meeting. Okay, Zoom video application is running, and here I can have my STS dev tool is running. Okay, which is this Spring developer, Spring tool suite, whatever we are using, this one, right? And on the parallel, you have another application open, which is Microsoft PowerPoint. Okay, PowerPoint. MS PowerPoint is working on the other hand. So if you observe, right, what do you understand by this? What do you understand by this?
Multiple programs are running in the same.
Yes. So in a single operating system, we are able to run multiple programs, right? So basically we were able to do multitasking. Yes or no?
Yes.
Multitasking, for example, you are making your breakfast, right? Say for example, you're making a toast, right? So what do you normally do? You take your bread slices and then you put some filling into it, and then you put it under toaster, and you will leave it on for say 2-3 minutes, right? And in the 2-3 minutes time, sometimes you stay at the toaster itself, you just wait at the toaster. Or sometimes if your toaster has a feature of automatically notifying or switching power off as soon as the food is cooked, right? So what it will do, you can just leave the toaster there that is, and you can parallelly make a coffee for you, right? You can parallelly make a coffee or have a sip of coffee while your toaster is doing. So as a human, we tend to do a lot of, this is multitasking, right? You're doing multiple things at the same time. So basically multitasking is all about that, okay? Doing multiple things at the same time. So if you see our operating systems, they are also doing certain sort of multitasking, right? Where you have so many programs, right? Which you can run parallelly. So in a typical technology terms, this Java, Zoom, SCS, PowerPoint, these are called operating system processes. Okay. So your operating system can run multiple processes. Every process can be this, okay? One can be a Java process, one can be a PowerPoint process, one can be a STS Spring tool suite process, your dev tools, right? Where you write code, and one will be a Zoom application process, right? So from operating system perspective, these are called process. So if you are on using Windows computer, if you ever went to this Windows Task Manager, right? This particular window, right? If you see here it says processes. You can see these processes, right? How much CPU and memory each process is consuming. Can you see here? You can see here, right? So for your operating system, each of these is a process. Spring Tool Suite is a process. Firefox browser is a process. Zoom is a process. Paint software, PowerPoint is a process. So it has so many processes like this. Okay. So, and within, understood till this point? Is it clear?
Yes.
So this is basically nothing but what's we can we say this as a this as a process based multitasking or not? Can we say that your operating system is also doing a process based multitasking, right? Which means it is
Yes.
running so many processes in parallel. Yes or no?
Yeah.
So having said that, in Java, we are specifically talking about thread-based multitasking. Okay, so this is called as process-based multitasking, right? But I said we are going to talk about thread-based multitasking. Okay, thread-based multitasking. So what exactly is the difference? Okay, within a process, like for example, let us take PowerPoint process alone, right? So in operating system level, running multiple things, you create these things is fine, right? But whereas in PowerPoint, let's take one process for example. Okay, so now I took suppose this is a PowerPoint process. Okay, so in PowerPoint again, this is a PowerPoint application, right? There are a lot of things to do. I can just move across the slides. I can insert. I can do a lot of things, or I can create a slideshow. I can increase the zoom. I can decrease it. I can format these slides. I can do a lot of things. Yes or no? As a PowerPoint application, I can do multiple things. But sometimes, what if there are multiple things in my PowerPoint application which need to happen same time, right? That means if I want to see multitasking within PowerPoint, how, right? You understood the question now? From the process based, you understood what is process based multitasking. Like if you take a single process, within single process itself, there can be multiple things that are happening, and we can definitely do those multiple tasks parallelly, right? At the same time. There also we can do multitasking. Yes or no?
Yeah. For example, like we can play a video in the PowerPoint and move the slides at the same time, something like that. Like
Yes,
two.
exactly, right? So we can do both at the same time. So how we can do a process within a process, how we can do multitasking, right? In process, every action user does is represented in a threads like this. Okay, you have threads in a process. Okay, like this. In process, there are so many threads like this. So each thread will represent multiple actions. Suppose if you, the example by you took playing video slide and video, and at the same time going through, iterating, looping through the slides. So playing video can be one thread and looping through the slides can be another thread, right? So within a particular process, there can be certain things which can happen simultaneously, right? So basically which can run concurrently. Okay, when I say running simultaneously, that is nothing but concurrent, right? Running at the same time, right? So basically this is what we are going to talk about within a process where there are multiple threads, right? How we ensure these multiple threads are doing multitasking. That means how can we ensure these multi-threads are performing their actions, or we can say executing concurrently, right? So this is what a multi-threading programming in Java is about. Okay, so uh, so basically your multi-threaded program in Java is nothing but it contains two or more parts of certain code of your application which can run concurrently, right? And each part of your such program is basically called as thread, and your thread will basically define a separate path of execution. Okay, so in that way, this we can call multi-threading as a specialized form of multitasking. Like if you see this code, for example, right, which we were writing some time ago, if you see here, your CPU will execute line by line, one line after the other, this line and then this line, this line, this line, this line, this line, this line, right? And what if you have a capability to execute these two lines and these two lines at this part at same time? That is what we are going to talk about. Okay, the multi-threaded programming. Understood? So why do we need multi-threading in first place, right? See, end of the day, whenever you're executing something, that means your CPU is internally executing that execution, right? So normally in early days, when people want so much computing power, they couldn't extend the capacity of the core chip processor to a certain extent. At certain extent, be any more efficient as it is. You understood the problem, right? In early days, if they want a high computing machines which do a lot of computing, so your computer will internally contain a processor, right? So that processor, it already reached a saturation stage where it can't be more efficient than what it is already doing. But then the scientists were doing, they still want more computation. So how they overcome is by they started adding extra processors. So that's why, and they call that particular computer as a dual core processor computer, sort of, right? So that's why you normally see dual core processors or core to duo or four core quad core processors, four cores, two cores, six cores, eight cores processors. So within a single computer, single or laptop, you can see multiple CPU cores. Like if you take these days, everything is, every computer that you come across will definitely have two cores. Okay, two cores for sure. It will contain two processors. So that means, so basically here, in order your thread to do certain thing, it should be able to take the time of CPU, right? If within PowerPoint, just going by our previous example, if playing video is consuming our CPU time, that is your processor time, then other thread cannot make use of the processor time to navigate through the slides, right? While the video is playing at the same time, we cannot navigate through the slides if at all the other thread couldn't get CPU time, right? Yes or no? So to handle this situation, like you have the dual core, like you have multiple processors. So on one processor, you will definitely have this thread which is playing the video, and another processor you will have another thread which is moving across the slides. So this is how we can handle it. But what if you have only one processor and you still want to handle this both things efficiently, right? With keeping one processor in hand, how you can ensure that all multiple threads within a process are executed concurrently at the same time? How can the thread-based multitasking can be achieved in case of a single processor? So this is what multi-threading in Java is going to talk about, right? So multi-threading in Java feature that allows concurrent execution of two or more parts of a program for maximum utilization of CPU, your processing time. Each part of such program is called thread. So threads are lightweight processes within a process, right? Understood the concept? What is multi-threading? Any queries on this, guys? Any queries on
So
this?
these threading happens in a single processor, right?
Yes.
Okay.
Within a single processor, like end of the day, your multiple things in a processors need CPU time too. Anything in your laptop definitely needs some processing time to do something. Right now, my PowerPoint is just sitting idle. It is not making use of any CPU time. But when I move across another slide, this is where it will making use of CPU time. So it will just check with CPU, right? Like if I basically click the left arrow or up and down arrows. So to respond to that, it might use some CPU time, right? So that is what I'm talking about when I say it needs us processing time. So multi-threading, we are talking about how efficiently within a single processor, how efficiently can we run these kind of things parallelly. That is what we are going to talk about in multi-threading, right? Understood?
Okay. Yes.
Okay. So in Java, how can we actually basically, create a thread, right? So in Java, we can create a thread using two ways. Okay. One is using thread class and another one is using runnable interface. Okay. So like say, for example, I'll just take my small program as a demo and we will see from there. Okay. I'll take the class, I'll say a thread demo. Okay. So let's assume I'm printing some numbers. Okay. Int a equal to 5, a greater than 0, a minus minus. This out. A. What is the output of this program? What is the output of this particular program?
5, 4, 3, 2, 1.
All right. If I run this, this is the output. 5, 4, 3, 2, 1. Okay. So basically, whatever code you written in this main method, it can be treated as a single thread. Yes or no? Right? And I'll call it as a main thread. Okay. Understood, right? So to actually retrieve information of thread, you have a thread class in Java. Okay, I'm not creating this. It is already available in the Java library, thread class. Okay, so I will take the thread class and I'll say thread class object in T I'll put. Okay, and here I will do. I need to get the current thread. That is the main thread, right? This particular main thread is what I should refer to. This is how I'll do. I'll say thread.current thread, and this 𝐿𝑗 will basically contain the information of my particular thread. Okay. So if I just try to print this thread, for example, I'm just printing this. Okay. 𝐿𝑗. What does it say? This is basically giving the main is nothing but name of the thread. Okay. And probably I'll just do something like this. 𝐿𝑗 dot set name, and I'll just give my thread some name like random name. Okay. I'll say suppose my thread name is Varsha, something like this. Now if you execute this, You can see, right? The name of the thread is being printed here, and it is being called from a main method. Okay. It's just simple output. There is nothing. But so your every thread will contain certain name. So in this particular example, wherever I am creating a thread, I am just uh, giving it some particular name, right? And not just name, right? You can just check multiple for a thread, what exactly it does and all, right? For example, let's assume I can put my thread to sleep also. Okay, I'll say thread dot sleep. For example, I want it to sleep for 1 second. Okay, 1 second may not make much difference. Suppose, okay, I'll put, say, for example, 5 seconds. Okay, but this thread sleep may throw an exception. So I have to put this inside a try catch. Okay, so like this. So now if I execute, what will happen? See, only 5 got printed. Our thread is sleeping for 5 seconds. Now 4 got printed. Now again thread is going to sleep for 5 seconds. Now 3 got printed. Now again thread is going to sleep for 5 seconds. 2 got printed. Now again thread is going to sleep for 5 seconds. And it will print 1. And as soon as it prints 1, our application execution is stopped there. Now you can see terminated, right? Understood, right? Because your 1 is greater than 0. So it can't basically sorry, it will eventually become 0. 0 is greater than 0 and your loop terminated, right? So we can basically put our thread to sleep also, right? Just couple of high level functions that I'm giving you. Okay, so we'll stop here, guys. So I would suggest you guys to go back, just do some reading on multi-threading. So tomorrow I'm going to discuss this at length, where I'll give you some examples of thread class and runnable interfaces, synchronization techniques, and all. A lot of important concepts that we are going to talk about tomorrow in our next class in multi-threading. Okay, so before that, I would want you guys to just go back and read something about it, right? So that you will have good questions to ask me and all, right? So I think we'll stop here for today. Any questions?
Could you paste that last program on the chat?
This one? Sure.
Yeah.
And have you guys started working on the Java assignment that I shared in our last class the other day? Have you guys started working on this Java assignment? These programs?
Was it shared through email?
No, I shared it in the chat itself, right?
Oh, okay. Oh, right. Yeah.
I'm sharing it again. Those who hasn't received it, please take it. Okay, please take it again. And if you see, you have certain programs. So I would want you guys to. So first 3 programs you can definitely start right away. Okay, the next set of programs you need certain concepts which I haven't covered yet. So I'm not going to talk about these, but first 3 you can go ahead and implement them and let me know on the status. Okay. So that's all, guys. Anything else you want to know? Any questions?